All right, so my starting values from the diagram are 10 volts from the battery. The left bulb is 20 ohms, that's a resistance. The middle bulb is 1 amp, that's a current. And the right bulb is 0.8 amps, that is also a current. So now I have to try to solve the rest. The tip highlighted in blue is not helpful yet because in each row here I've only got one item. So I have to start thinking about the voltage law or the current law. In this case, I'm going to start out with the voltage law. So the voltage law says in every loop in the circuit, the voltage gains equals the voltage losses. Now this is a parallel circuit. There are 3 loops in total. I'm going to draw them out. So here's the first loop. So I'm going to start that over actually. I want to draw it in order. So if I start at the battery, come around and turn down the first pathway through the first light bulb and then go straight back to the battery, that counts as a loop. So in this first loop, there is 1 light bulb, and therefore the 1 light bulb is going to receive all of the voltage from the battery, which would be 10 volts. And the exact same thing happens for the middle loop. So I'll use a green highlighter. So start at the battery. This time, the charges choose to go through the middle pathway and then back to the battery. So all those junction points are just charges choosing a direction to go. So here's the second option. I call it the second loop. So in the second loop, same thing. There's only 1 light bulb using any voltage in that second loop. So it's going to use all 10 volts provided by the battery. And similarly, I'm not going to draw this out, but the same thing happens for the third and final loop. That light bulb is the only thing in that loop. So it will also use all the voltage provided by the battery, which is 10 volts. So having done this, it allows me to calculate a lot of values now. I'll start with this value right here, the current of the left bulb. Using Ohm's law, the current equals voltage divided by resistance. We've got the numbers 10 volts and 20 ohms, so it's 10 divided by 20. That's half, or 0.5. So that's the current going through the left bulb, 0.5 amps. I'll write it in the diagram as well. I can go try to find the middle bulb's resistance. So I'll just say middle R for resistance. So here's Ohm's law's formula. For the middle bulb, I can fill in 1 amp equals 10 volts divided by something. So 10 divided by something has to equal to 1. Well, that's going to be 10 divided by 10. So the resistance is going to be 10 ohms. So I'll fill in 10 right in the middle there. And also this resistance for the right bulb, same thing, well, same sort of thing. I equals V over R. This time for the right bulb, the current given is 0.8 amps equals 10 volts divided by something. So 10 divided by something has to equal to 0.8 this time. So that one's more difficult to do with mental math. So if I use algebra, this will rearrange to be R equals 10 divided by 0.8. So I'll go to the calculator now and type in 10 divided by 0.8. That gives me 12.5 ohms. Okay, and the last thing to find would be the current through the battery. That's the last unknown here, the current through the battery. So I have to use a current law to do that. So whatever the current, however many amps is going through the battery, I'll draw the pathway here. So you have such and such amps going through the battery, and then it gets to this first junction point. So however many amps it was, it looks like 0.5 amps goes down the first path. The rest of it would continue on until it reaches the next junction, where it looks like 1 amp goes down the path of the middle bulb, and then 0.8 amps goes to the final pathway. So I'm going to, in red, write out the amps here. So we have 0.8 coming out here in 1.0 or 1 coming down here. That means how much amps had to be going into this junction in the first place. That means there had to be a total of 1.8 amps going into that junction. Amps split up at the junctions. Similarly, I can backtrace this. So 1.8 amps came this way, and 0.5 amps went down the first pathway. So therefore, how many amps had to come from here? Well, a lot of amps had to come from here. 1.8 plus 0.5, basically. 2.3 amps had to come from here. And working backwards like that is how you come up with the current that came from the battery. So 2.3 amps. I don't need to write the units in this table because they're all in the headings already. Okay, so that would solve this circuit.